H. Pal, Mr. Cook. And yeah, this stuff's gonna be really easy with a calculator. Let's go through it. All right, so group work. Cleared out my calculator. Let's see what we got. Entering these matrices in your calculator is gonna be pretty easy, and then the operations are pretty easy as well. First, we go to the matrix option. So you hit second blue button, and then see how it says matrix. So a few buttons down, press that. So it's the inverse button. And then we go to edit edit our matrices. And then we enter the dimensions. So this is a 3 by 3. So we do 3, enter, and then 3. And it changes the size of the matrix on your screen. And then just enter all those values in 2 and 1, 4 and 0 and 3, and then -1, and then 1 and 1 and 2. -2, I'm sorry. Okay, so you enter that in and then you quit out. So second and then mode. And then you enter your next matrix in. So go back to the matrix menu, go to edit, matrix B. This is another 3 by 3 matrix. So we enter those in. And then 1 and 2 and -1. And then -1 and 0 and 3. And then 3 and 4 and -1. Okay, and then our last matrix is matrix C, so let's enter that one in as well. Go to the matrix menu, edit, matrix C, and this is a 2 row by 3 column matrix, so 2 by 3. And then we enter -1, 3, -2, and then 2, and then 1, oops, and then 1, and then 4. Okay, so now we just do all the operations that they want, and we'll just write up what we get. Okay, so we got to do matrix 2 times matrix A plus matrix B. So we do 2 and then times, and then we go over to the matrix menu, and instead of going to edit, we just stay with the names part, and we just hit enter. So 2 times matrix A, and then plus, and then we do matrix B. Then we hit enter, and we get our result. So 5, 4, 7, and then -1, 6, and then 1. And then 5, 6, -5. Okay, and then we do the next one, A times B minus A. So, you do matrix A times matrix B, and then minus matrix A. And then hit enter, and then you get your answer. So part B is 11, 19, -7. -6, -7, 11, -7, -7, and 6. All right, C times A. Let's see here. So we do matrix C times matrix A. And enter, and there's our answer for C times A. So we have a 2 by 3 matrix, -4, 6, -3. 8, 9, -1. All right, B times C. You can't do B times C. So B is a 3 by 3 matrix. You're multiplying by C, and that's a 2 by 3. So the dimensions don't match up, so this is not possible. Your calculator will say that too. You need to be able to recognize it. So if I try to do B times C, you go B and then times and then C. And look what happens. It's like, oh, I can't do that. That's, your calculator saying that, hey, those dimensions don't match up. And now we can find the matrix B's inverse as well pretty easily. Here's how you do it. You do, matrix B. And you know how we got to matrix? We press that button X -1 in the lower left corner right below the math button. We just press that once, and then it brings up inverse. And then it'll give you the inverse. And here's another cool thing. You can turn this into fractions if you want. If you just do your math frac thing, math and then 1 and enter. See, I'll turn it into fractions. I kind of like to write it up like that personally. So 3/2, -1/4, then 3/4, 1, 1/4, then -1/4. Ooh, that hardly looks like a 4. There we go. -1/2, 1/4, and a 1/4. There you go. Isn't that fun? All right, next up, find the determinant of each matrix using your calculator. I mean, you don't have to. Look, a 2 by 2, just use your, 2 times 3 is 6, minus, and then it's negative 20. These are the little rules that we come up with, so 26. You can actually do that faster than your calculator. This one, a 3 by 3 is a little bit tougher, so, might as well just do that one. So matrix B, so you enter it in. And it doesn't matter what matrix you use. I'll just use the B because, I don't know, for typing purposes, maybe it's a little bit faster to do it this way. I don't know. But you can call it matrix A. It doesn't matter. -1, 3, and then 5, and 2, and 0, and then -7, and 1, and -4. Okay, there they are. And then here's how you get to the determinant. So you go to the matrix menu, and instead of going to names, instead of going to edit, you go to math, and then determinant's like the very first one. So determinant of matrix B, hit enter, and there's your determinant, 21. So determinant of B is equal to 21. All right, there we go. Oops, and I should write that probably over here instead of saying that's equal. It's not true. This is 26, though, the determinant of A. Find the inverse of the following matrices. Again, you could probably do your little rules for this maybe a little bit faster. I don't know. Let's see which one's faster. So -1. If I do the determinant, that's 1 over 6 minus 5, so 1. And then I just switch the D and the A values and then negate the other ones. There you go. There's my inverse. Let's see if how fast I can do that with the calculator. Oh gosh. So let's see here. Got to make it 2 by 2. So we'll go to edit, 2 by 2. And then it's 2 and then 5 and then 1 and then 3. And then inverse. So you do matrix A and then inverse button. Okay, same thing, right? But maybe it took me a little bit longer. I don't know. All right, let's do the next matrix, matrix B. So it's inverse is going to be equal to what? Let's find out. So second matrix, 3 by 3, and then we've got 1, and then -2, and then 3, and then -1, and 3, and -1, and then 2, and then -5, and 5. All right, then we do matrix A, and then inverse. And there you go. There's our inverse matrix. So we get 10, -5, -7, 3, -1, -2, -1, 1, 1. All right, there's our inverse. Solving matrices practice. So solve using RREF. So we type this in as an augmented matrix first. So let's write it up as an augmented matrix. 1, 1, 1, 4. And then 2, -1, and then we don't have any z's in that one, so 0 for the placeholder. And then -2, -3, 4, and 0. All right, and then we use REF on our calculators, and it'll spit out some answer, and that'll give us our solutions. So it'll look like this. It'll be an identity matrix. And then it'll give us like some numbers over here. These are going to be like our X, our Y, and our Z values in a second, okay? So let's see what we get. All right, here we go. So matrix, then edit. And now it's 3 rows and 4 columns on that augmented matrix. So we do 3 by 4. And then we enter all the values that we have. So 1, 1, 1, and 4. And then 2, and -1, and 0, and 12. And then -2, -3, 4, and 0. All right, and then we just REF. So we go to matrix, and then you go to math, and then REF is kind of towards the bottom. So I just press up to get to the lower part, and we want REF, reduced row echelon form. And then our augmented matrix is stored as matrix A, so we do REF of A, and that gives us our answer. There's our identity matrix, and then we've got 5, -2, and 1. So it tells you all the values that you're going to need, X, Y, and Z. In this particular system of equations are equal to 5, -2, and 1, respectively. So there you go. That's using reduced row echelon form. Solve using the inverse matrix and show your steps. Okay, no problem. So first what we do is we identify some matrix A, which is the coefficient matrix. So we just write out the coefficients. So there's three rows and 3 columns for this. We ignore this stuff for right now, okay? So we just write up all the coefficients, 1, then 3, and then 1, -1, -2, and 3, -2, -5, and 3. And then we find the inverse matrix. So A inverse is equal to something. It's going to be a 3 by 3. Let's see what we get. All right, so matrix A, edit. It's now a 3 by 3. We've got 1 and then 3 and then 1. Then we've got -1 and then -2 and then 3. And then we've got -2 and then -5 and then 3. All right, now we find this thing's inverse. So matrix A inverse. So that's what we get. So it's 9, -14, 11, and then -3, 5, oops, -3, 5, -4, and then 1, -1, and 1. And then what we do is we take this, let's say that this is equal to like, some vector B, okay? And we take A inverse times B, and that'll give us all of our values, X, Y, and Z, okay? So let's see what this is going to be equal to. So we type in our inverse matrix now. Or, that's what it is, that. So let's do A inverse, and then times, oh wait, we got to make that little vector of the solutions, the B vector. So I got to make a little vector that's like 8 and then 6 and then 1. All right, so let's do that. Let's call it B. And this is 3 rows and 1 column. And then it's going to be 8 and 6 and 1. There we go. And now we'll multiply this times B. And that gives us our answers. So X, Y, and Z are equal to -1, 2, and 3 respectively. There you go. That's all you had to do. So what I did was I found the inverse matrix, and then I multiplied it times B, which is like all of these little guys right over here. And that should give me my X, my Y, and my Z. Okay, using Cramer's rule to solve the system of equations. Okay, piece of cake. So it's just like a bunch of determinants, basically. Let's see here. So coefficient determinant, determinant of X, determinant Y, determinant Z. And then you just make a bunch of fractions out of it. So let's do the determinant of the coefficients first. So that's going to be like the coefficients of all of like this stuff right here. Okay. So we do 1 and then 1 and then 1, -1, -3, and 5, and then 2 and then 1 and then -3. So now we do this thing's determinant, and that's what we're going to put like over here. Okay. So let's type that into our calculator. Matrix A, edit. So it's a 3 by 3. And then those numbers are 1 and 1 and 1. And then -1 and then -3 and then 5. And then 2 and then 1 and then -3. All right. And then let's do this thing's determinant. So matrix, math, first thing determinant, and then math A. There we go. So this thing's determinant is 16. Now we're going to find the determinant for X. So that's where we take like the X column, which is like the first column, and we replace it with these numbers. So 0, -2, and -4. And then we do the determinant again. So let's do that. And this will give us the determinant for the X value, the next one after. So let's go over to our matrix and edit it. And we're just going to edit the first column. So we're going to turn that into a 0, and then a -2, and then a -4. And that should be it. And now I find this thing's determinant. So I can do the same thing as before, determinant of A. Now I get -40. So -40 goes here. And that can give me my X value. My X value is going to be equal to -40 over 16. I'll reduce that in a second. Let's get the next one, the Y value, okay? So the Y value, what we're going to do is take the determinant of the Y matrix and then divide it by the coefficient determinant. So next up, now we replace all of those values back in here, the 1 and the -1 and the 2, we return it back to its like original form when it was the coefficient matrix. But now we get rid of the y values and we replace it with these guys over here, 0, -2, -4. Remember this from Cramer's rule? We're just like replacing some stuff and finding determinants. Really, the only reason we ask you to do this is because like we didn't expect you to do this with 3x3 matrices because the determinants can be pretty like, can take a while. But now that you have your calculator, it's pretty easy. All right, matrix, edit. And then let's see here. So the first column, we're going to replace those values, 1, and then -1 and 2. And now the second column, we're going to change that to the 0, -2, and -4. So 0, -2, and -4. Okay. And we're going to do the same thing. We're going to take the determinant again. So we get 34 this time. So now 34 goes here. So that means that y is going to be 34 over 16. And we'll be able to reduce that in a second. Now let's get z. Let's figure out what the determinant of z is going to be. So what we do is, we keep the y values. We replace those back with what they originally were, 1 and -3 and 1. And now the z column we replace with 0, -2, and -4. And, type it into your calculator again. So matrix, edit, 3x3. Let's replace that second column back with the original y values. So 1 and -3 and 1. And then, now these ones, the z values are going to be the 0 and the -2 and the -4. There we go. Okay, now we do the determinant one more time. And it looks like it's 6 this time around. So 6. So we get 6 over 16. And then you can reduce the fractions a little bit. 40 and 16 are both divisible by 8. So that'd be 5 over 2. 34 and 16 are only divisible by 2. So that'd be 17 over 8. And 6 and 16 are only divisible by 2. So that'd be 3 over 8. But, overall, that should be the solution to this system of equations. Yeah. Okay. All right. So there you go. There's the first page. I figure that for the application stuff, I don't know, we'll do that on a separate video. Okay. So that's it for this one. See you on the next one. Bye-bye.